for two congruent triangles. So the first thing I want to talk about is the principle of superposition. So this says that if a geometric figure can be mapped exactly to another geometric figure, then they are congruent. And by mapped means that we can basically figure out a way, whether we've turned it by rotating it, reflecting it, translating it, we've done something to make sure the shape stayed the same, we've just put it in a different place on the paper. Two polygons are congruent if and only if their corresponding parts are congruent, and those corresponding parts are what we consider the matching parts. This is also true that two polygons are congruent if and only if a rigid motion or series of rigid motions, such as a reflection, rotation, translation, is what maps one to the other. So in this case, I have two triangles that are congruent, and I can tell they are congruent by these weird markings on them. So I put tick marks to mark to say that sides are the same. So AB only has one little dash on it. XY has a little dash on it. So I say that AB is congruent. That's what this weird symbol means. Squiggle with the equal sign is congruent to XY. BC has 2 marks on it. YZ has 2 marks on it. So they are congruent. CA and ZX have 2 or 3 marks each. So those are congruent. And with the same concept here, my angles have curved marks, but it's the same idea. A and X each have 1 little curve on them, so they're congruent. B and Y have 2 curves, so they're congruent. And Z and C have 3. All right, so in these examples, what we want to do is really read off those markings to figure out, to show that they are congruent. So we want to prove all of these things are true. So if I take a look here, I see that angle A has 1 marking on it. So what does angle A match up with? That's angle X, which has 1 mark. Angle B is going to be congruent. That's 2 markings. Angle Y has 2 markings. And then angle C. Angle C has 3. Z also has 3. So those are my congruent angles. Now I want to make sure that the sides match up. So I'll start with AB. And AB has 1 dash mark on it, so does XY. Then BC has 2 dash marks on it, as does YZ. And let's see, CA has 2 or 3 dash marks, and so does ZX. Okay, so now I've said that all of their corresponding parts are congruent, which means that triangle ABC, and I'm kind of just following this order, right? A, B, B, C, C, A, like connecting the dots. A to B to C, right? If I draw them, A, B, C. And order does matter. So triangle ABC is congruent too. And then I go from X to Y to Z. From X to Y to Z. So triangle X, Y, Z. Okay? And then if we were worried about the rigid motions, it looks like all we've done is really kind of rotate this thing and move it over. Okay. All right, let's take a look at the next one. So again, we have our angles. Angle A has 1 marking on it, so that will match up with angle W, which has 1. Angle B has 2 marks. Angle X has 2 marks. Angle C has 1, 2, 3. Y has 1, 2, 3. And angle D and angle Z both have 4 marks. And then we're going to do the same with sides. So we have side AB, which has 2 dash marks on it, and WX has 2 dash marks. Then we have side BC with 1 dash mark, and side XY. We have CD has 4, YZ has 4, and DA has 3, as does ZW. And when I'm doing this, I'm really kind of purposely going around. So I started at A and I went to B when I just kind of chose my order here. So from A to B to C to D. So I would call this shape ABCD. And that is congruent to, I started at W and ended at W. So WX went from W to X to Y to Z. So WXYZ. The order that you write these letters in really does matter. All right, so they don't necessarily have to put marks. They could give us numbers. So the values, if they are equal, they are congruent. So let's see, let's start, I don't know, I'm just going to go alphabetical. So let's start with J. So angle J is 52, which means that's congruent to something else that's 52. So that's angle P. Angle K is 78. Who else is 78M? And then angle L is 50. 1, 2, 3. And the other 50 is Q. Okay. So the next thing I want to do is my side. So I'm going to just start alphabetical again. So I'm going to go JK is congruent to. So that's 39. 39 and 39 are going to match. So M or PM. Okay. Then we have KL, just kind of following it around. So we have 40. And so PM, MQ is also 40. And then lastly, we have LJ, which is 50. And that matches up with our other side, that is 50, QP. So we say that JKL, and I'm just kind of reading down the side, is congruent to PMQ. The phrase if and only if in the congruent polygon definition really means that both conditions have to be true. And its converse are true, the conditional and the converse. So if two polygons are congruent, then their corresponding sides are also congruent. So if we know it's congruent, we can work backwards. This is a really big one, and it's going to come up again later when we start to do proofs. But we say that corresponding parts of congruent triangles are congruent. We shorten that to CPCTC. Corresponding parts, matching parts, of congruent triangles, triangles that are equal, are congruent. CPCTC. CPCTC. We're going to use this again this chapter. All right, so what this is going to allow us to do is basically to read this statement. And this statement is so important. Using this statement, I am going to be able to tell which parts match up from the triangles. I just read it in order. So since A is the first letter that shows up, that's the angle that's going to match with the first letter over here. So A and D are going to be congruent. Okay? Because the middle letter is B, B and F are going to be congruent. All right? And then because the last letter is C, C and E are going to be congruent. We also can do this with the sides. So A, B are the first two letters, D, F are the first two letters. The last two are B, C. The last two are F, E. The outside letters are A and C. The outside letters are D and E. It's all about where they are written in that statement. Okay, so now we can use that information to solve for X and Y. It looks like it's actually going to be more helpful to find Y first. So it looks like we have this angle here. 8y minus 5 is referring to this angle in here. So angle B and F we know are congruent, which means that the measure of angle B is equal to the measure of angle F. So we can say B is 99, and F we said was 8y minus 5. And now let's find Y. So we're going to add 5 to both sides. That's 104 equals 8y. And then when I divide, we get 13. Okay. The next thing I'm going to do is find X. So I see we have 2y plus x. So we could make life a little easier and put the 13 in place of the y now. So that's 2 times 13 plus x, which is really going to be 26 plus x. So this side here, EF or FE, is 26 plus x. That is going to be congruent to the other side that also has 2 dashes, side BC. So we can say that BC is congruent to FE, which means BC is equal to FE. So 38.4 is equal to 26 plus x. And when I subtract, that gives us that x is 12.4. So in this diagram, we see that triangle S or RSV is congruent to triangle TVS. So again, we want to do the same thing. First letters go together. R and T are going to be congruent. Okay. Then we also know that the middle letters, S and V, are going to be congruent. So S we see is 90 degrees. So V is going to be 90 degrees within that triangle. And then again, we have V and S match up, but on the other side. So really they're referring to these angles. Okay. All right, so we have the same kind of rules going on with the sides here. The first two letters match up, so we have RS and TV. RS, TV. SV and VS, which is really the same side here in the middle, matches up. And then the outside letters, RV and TS or ST. Okay, so now we can find our variables. So X is that yellow angle. I don't have the other yellow angle, but I do have something else. I know that kind of looking at this triangle here, actually it doesn't matter which triangle I look at. It actually might even be easier to do the other one. Let's do the other one. So if I look at triangle VST or STV, however you want to say it, this is X in the corner here. We already know this is 90 degrees. And this corner up here is the same as the other green, so it's 78. We can use what we learned in 4.1, that the inside angles add to 180. So we have X plus 90 plus 78 equals 180. 90 and 78 are going to give me 168. So when we subtract, X is going to give us 12. Then we need to find y. Y is referring to this line with the single tick mark, so that should equal the line with the single tick mark. So 2y minus 1 is 24. Add the 1, so 2y is 25. And when I divide, I get 12.5. We have the third angles theorem, and this says that if two angles of a triangle are congruent to two angles of another triangle, then the third angles of the triangles are congruent to each other. So if I already know that two of the angles are congruent, then I know that all of the angles are congruent. Okay, so we're going to use that to help us solve these. So we have that angle NPQ is congruent to angle RST. So NPQ, that's this curve down here, is congruent to RST. So that's this little curve down here. And we also know that NPQ is 40. Find SRT. SRT. Okay. Well, if we know that NPQ is 40, right, this is 40, then we also know that the congruent side is 40. So we're going to really pull out this triangle. Okay. RTS. Since P is going to be 40 in here, we also know this is 40. That's because they're congruent. We see this little 90-degree box, so in order to find angle R, we can find that pretty easily just by doing the angles add to 180, right? So 90 plus 40 plus angle R is going to equal measure of angle R, 180. So that's 130 plus the measure of angle R is equal to 180. So that gives us angle R is going to be 50, or I guess more specifically, SRT is going to be 50.